Okay, we have seen this example before on how to use test of hypothesis to test for one mean when we know the population variance. Now we will use the same data and same hypothesis to be tested inside Matlab. So firstly, we have the measured data. Here we have 9 samples. We have the hypothesis of mean if it is equal to 500 versus it is not equal to 500. So we have two-sided hypothesis. We already know the population variance to be 4. We have the sample size, which is number of items or number of measurements. We have 9 measurements. We will use the most common confidence level, which is 95%. So now we go to Matlab. Firstly, it's a good practice to clear all variables and clear the command window, also to close all figures. So the first point is to initialize the data. Now we have the data vector. In fact, this data is nothing more than the measured data in this table. So we have 9 samples. I already copied these 9 samples. Here in one vector we separate by a space. We can also separate by a comma. So now first step is to measure X bar. In Matlab, we measure the mean of sequence of data by the command mean of data. So the command mean of data will calculate the average or the mean of data and store in the variable called X bar. Okay, now we also have the command to find the number of samples in the data. We have length of data and also store in n. So n will be the number of data inside this vector. Now we have to define the hypothesis itself. We have a mu equal to 500. This is our hypothesis. So we have a mu equal 500. We have sigma equal to, or sigma square equal 4, the same. We have the variance equal 4, so we just define sigma equal 2. Now the first step in solution is to calculate X bar, as we have seen in Matlab, also to calculate the test statistic, which is Z0. We have Z0, which is the difference between X bar and hypothesized mean. We divide by sigma divided by square root of n, which is number of samples. Now so we can calculate the Z0. After that we use this value to test our hypothesis. So we go back to Matlab. So Z0 is just only X bar minus mu. We divide by sigma over square root of n. N is number of samples. So now the important point is to find where are the limits. Previously we have seen in lectures, here we have the standard normal distribution. In between or in the center we have the 95%, which is the confidence level. We have 95% inside the normal distribution. We have two rejection regions. We have to the left 2.5%, also to the right 2.5%. So now the important thing is to find this point. Here we found it 1.96. Also to the half side to the left minus 1.96, because the normal distribution is symmetric. Okay, so how to do this in Matlab? In Matlab we have the function norm inverse. So in norm inverse we give the cumulative probability. This is the cumulative probability, which is 0.975. We give the 0 mean and 1 for standard deviation to have the standard normal distribution. So why we do this? We do this to find this point to the right, which is 1.96. So in fact the cumulative distribution function, or the area under the curve, from minus infinity to this point will be 0.975. So we want to find the point in the positive side that has the area under the curve from minus infinity to z. So from minus infinity to z, the area under the curve will be 0.975. After finding this value of z, we will decide if z naught is between z and minus z, we are going to fail to reject the null hypothesis. Otherwise, we are going to reject h naught. So if z naught is inside the acceptance region between minus absolute value of z and absolute value of z here, so if z naught is in this acceptance region, we are going to fail to reject the null. Otherwise, if z is in this side rejection area or this side rejection area, we are going to reject the null hypothesis. I will display this statement in the command window by using the command display or disb. Now I can run only this section of code. I can run this section. Okay. So firstly, we notice the following. As a result, in the command window, we have seen fail to reject h naught. So this is the conclusion of our hypothesis testing. But firstly, we can go also to see in the workspace, we have a mu already defined 500. This is mu. We have the data vector. This is the data vector that we have defined. We have n is the number of samples we can get by length of data. We have sigma already defined here, 2. We have x bar already calculated by Matlab using the command mean of data. We have z here. This is the critical value from standard normal distribution. So now z is 1.96, the same as we have seen from tables before. This is 1.96. Also to the left we have minus 1.96. Also z naught. For z naught we have found minus 0.43. Here we have z naught minus 0.435. In fact, there is some approximation, so no problem. So z naught in fact lies in between the acceptance region. That's why we have this if statement. This statement was executed. So we are going to fail to reject the null hypothesis. In fact, we can do more interesting coding, and results can be viewed more clearly by graphing. We can graph the normal distribution using Matlab. So we can graph from -4 to 4. In fact, as we know, the normal distribution before -4 and after 4 approximately 0. So from -4 to 4, this is more than sufficient. We can plot firstly x-axis as x and normal PDF of x. We can also hold on to a graph in the same plot or same figure. Now we want to graph the rejection areas. We have two areas. First one from -4 to -z. Second area from z, the positive side. Here this is the positive side. This is the negative side. The positive side from z to 4. We have two areas. We can draw the area 1 and area 2, also using y1, y2 and norm PDF of y1 and y2. Also, there is an interesting point. We can have the graph of z naught. So z naught in fact is only 1 point, as we have seen. Z naught is only 1 point. We can use the graphing function stem to draw one sample or 1 point. So we're drawing z naught and also norm PDF of z naught. Here we have an option, for example, to graph in red color, so we can have more clear and more indicating graph. Now I can run all the code together by this command. Okay, now this is the figure we have. So now our conclusion is we are failing to reject the null hypothesis. Now from this graph, firstly, the first plot here from -4 to 4 is the standard normal distribution. We have graphed also two areas. This area shaded and this area shaded are the rejection areas. First one from minus 4, and actually from minus infinity, but here we have only from minus 4 to minus 1.96. The second rejection area is from 1.96 to 4. Now we graphed also in red, we have the Z0. So this is the value of Z0. We notice Z0 lies in the acceptance region. So as long as Z0 lies in the acceptance region, we are going to fail to reject the null. We are also possible to have the value of Z0. We have the data cursor here. We can click directly or exactly at this curve to find, yes, the x-axis is minus 0.433, which is the same as here as Z0 value. So now the conclusion is, from the graph and from the code of Matlab, we have concluded that we are going to fail to reject the null hypothesis under the given information. So this conclusion is the same as we have seen before in the same example, using normal probability distribution tables and old methods using test of hypothesis.